Sure. This is the session on beyond composting, and everybody in the right place? Super. We've got two presenters today. The first is Kate Wetbeck. Kate's one of the owners of Momentum Recycling, which is a zero waste company providing recyclable and green waste collection services to the Salt Lake community. The company recently expanded glass processing and built a clean and crushed recycled glass center, I guess. And if you haven't been out to that, they're kind of proud of it, and it's really an interesting. We are. Yeah. And you should be. It's really an interesting process they go through. So if you want to see that, just talk to Kate afterwards, and I'm sure they'll set that up. Kate's got a broad range of responsibilities at Momentum, including sales, client training, and public education. She's providing consulting services on waste reduction through sustainable purchasing, materials use, creative reuse, and recycling. She's a seasoned scavenger. She serves as the Momentum's waste audit expert, and she's worked as co-chair of the Salt Lake Mayor's Green Team, and currently sits on the advisory board for the Utah Society of Environmental Education, and she also sits on the URA board as well. And she lives in Salt Lake, and her husband have 2 kids. So there's probably not much more to say about Kate, right? Yeah. Our partner in crime today is Glenn Perry, and I actually had a chance to listen to these guys give this presentation about 3 weeks ago, I guess, and it's really interesting, and I think really putting our best foot forward, and so it's going to be interesting to hear it again, because I'm going to really be paying attention this time. Glenn's currently Vice President for Alder Construction Company, and also All Pro Energy and Water. They're out of Salt Lake City. Glenn oversees the day-to-day operations of the company, including project management, purchasing, market development, equipment maintenance, and field operations. He's got over 20 years' experience in the construction industry. Experience has been in a variety of areas of construction, from heavy site work and civil construction to multifamily, residential, and land development construction. Majority of Glenn's career has been in the management of the construction, large water and wastewater treatment. Over the course of the last 3 years, Glenn's had focus on efforts on the development of new markets for the Alder construction, including the formation of All Pro, which I'll talk about today, energy and water, and for the sale of developing waste to energy and water reuse projects in both the public and private sectors. So please welcome Kate and Glenn.
Thank you, Steve. Thanks for everybody for coming to listen to us right after lunch. I'd like to have, if we can, I'd like to kind of keep this, it's not a huge crowd, so if you have any questions that come up that you'd like to have answered as we go along, just feel free to stop us, and we'd be glad to answer your questions the best we can, and at the end we should have time to answer some more as well. So I'm going to start off the presentation today by discussing a little bit about what anaerobic digestion is. How many people in here have heard of anaerobic digestion? So a good group. Anaerobic digestion, I like to describe it basically as a stomach, giant stomach. That's probably not exactly accurate, because it's more like a stomach and intestines together, basically your digestive system. But we as humans are anaerobic digesters. So basically, a good rule of thumb is when you think about what we can take into an anaerobic digester, if you can eat it, good chance that we can take it into an anaerobic digester. So, with the exception of manure, you don't want to eat manure. You'll take municipal waste, organic waste, manure from large animal operations, comes into an anaerobic digester, which is basically a large vessel that is free of oxygen. And inside of the anaerobic digester You have a bacterial process that takes place and reduces the volatile solids down to less than what you put in. And as a result of that, there's a gas, what we call biogas, is produced. And if you, for those of you in the back that can't see this, basically it's 65%, roughly 65% methane and 30 to 32% CO2 in that range. And then a few other miscellaneous, a little bit of hydrogen, a little bit of nitrogen, a little bit of H2S, hydrogen sulfide, which makes up the 100% of the biogas volume. And with that, what we're talking to you about today is taking that methane and also the products that come out of the anaerobic digester and converting them into a useful asset, whether it's electricity, a gas or a fuel, or a fertilizer product, and in some projects, all three. So that gives you kind of a quick background on anaerobic digestion and what it is and what we're talking about. AD, as I'll refer to it today, AD is right now one of the most economically viable, really the only economically viable way of dealing with organic waste. There's lots of technologies out there, gasification and several different miscellaneous technologies that are kind of being touted as another way of dealing with organic waste. But really, a lot of those technologies are not commercially viable. And anaerobic digestion has been used for a long time, over 50 years in the treatment of municipal wastewater, and it's a big part of the infrastructure in Europe on the food and organic waste disposal. I'm going to just really briefly go through kind of who Allpro is and where we came from and how we kind of arrived at this project. We won't spend very much time on this. Allpro is made up of two major entities. Alder Construction is a general contractor that's been building water and wastewater treatment plants in the western half of the U.S. for 50 years, and I've worked for Alder Construction for over 20 years in that capacity. And our engineering partner on these projects is Aqua Engineering and their electrical engineering firm, SKM. We formed Allpro for the purpose of developing projects that we're going to be talking to you about today. Momentum Recycling is one of the feedstock suppliers that we're working with. Momentum is focusing more on the organic food waste side of things, or the food waste side of things, and specifically the source separated organics, package type food waste. We're actually diverting MSW from the landfill. Then we have a partner that deals with the offtake of the energy, the carbon-based fertilizer, which we'll get into in a little bit, that we're working on, as well as a digestion technology and packaging technology partner. So these projects take a long time to develop. So there's a pretty extensive process in kind of how you go about developing one of these projects. First thing that happens on a project like this is you do an extensive feasibility analysis and feasibility study. And really the purpose of that is to determine your capital expenditure costs, your operational expenditure costs, and whether there's a return on the investment or not. And we love to do these projects for the sustainability side of the projects, but they have to be economically viable in order to be able to be financed. So that's the first step in the process. From there, you usually get to a memo of understanding, some type of a definitive long-term agreement, and along with that comes long-term feedstock agreements, long-term energy offtake agreements, and some type of a project company ownership structure that makes up these projects. And these two items right here, bankable long-term feedstock agreements and bankable long-term energy offtake agreements, are the key to a successful project. Without those, they'll never get financed. So the financing would come after you have the long-term agreements, permitting, and design, build, and construction, operation and maintenance. And right now, the projects that we're working on here on the Wasatch front, we're hoping to break ground on them by later in 2015, and they'll have around a 12-month construction schedule. So we're in around a year and a half to 2-year range before we'll actually be up and operational with the facility we're going to talk about today. We've currently been working on these projects for over 3 years. So it gives you a little bit of a perspective into how long it takes to develop one of these projects and how hard it really is. And really the biggest reason is because there's so many moving parts. And when I say that, it's the digestion process is relatively simple, but all of the feedstock to be able to develop a constant flow of waste coming into these facilities is really, you have to secure that stream in order to be able to finance the project. So I'm just going to run through some 4 or 5 different types of anaerobic digestion. This might be kind of hard to see. I mean, there's a mesophilic anaerobic digestion. A mesophilic refers to the type of bacteria that's in the system. Our bodies are mesophilic digesters, and they run at around 98 degrees. You have a thermophilic anaerobic digestion, and you have what they call a thermophilic mesophilic, or TPAD, which is in series. You'll come into the thermophilic first, and then the mesophilic, and you, without getting into a lot of the science of digesters, basically what you have is you have bacteria that's attacking different, whether it's the long chain fatty acids or there's different bacteria that attack different types of organics in the waste. So you get more energy if you're able to use more than one type of just bacteria. That's the purpose of the TPAD. There's also an advanced digestion process using what's called a biological hydrolysis. It's actually an enzymatic hydrolysis process that it's like the acid phase of the digester, which would be more like your stomach, and then the bacterial phase would be more like your intestines. And basically what it does is it starts the digestion process, breaks down the cell wall, and allows that organics that are tied up within the cell to be more available to produce gas. This is actually the technology that we'll be using on our projects, is a biological hydrolysis process. Then the last one I'm going to talk about is a thermal hydrolysis process, and this utilizes some type of a heat source, usually steam, and it's accomplishing the exact same thing as what the biological hydrolysis is accomplishing. It's breaking that cell wall, and it usually uses steam or a high heat to burst those cells, and once it bursts those cells, it makes that carbon that's on the inside of the cell more available to the bacteria for breakdown. So the purpose of these two here is to increase your volatile solids destruction inside the digester and increase your gas production. So as we're looking at these projects from a capital expenditure standpoint, these 2 systems on the bottom here are more expensive to build than the top 3 systems. So you have to look at, am I going to increase my gas production with a high enough quantity to justify the additional capital expenditure? All the digestion processes use a specialized equipment or technology provider. That's just kind of a basic disclaimer. None of these, especially these bottom 2, are not something you'd ever build in your backyard. 4 main areas where AD is used. Agricultural, you may have heard of big agricultural digesters. A lot of dairy farms now have agricultural digesters to digest the cow manure. It was more popular a few years ago when there was more grants available. Some of those grants have gone away, so some of the agriculture digesters have struggled a little bit from a financial viability standpoint. Greenfield standalone systems. We're seeing a few of these develop in the U.S., but a lot of greenfield digesters in Europe. That's a field that's big over there, where basically just go out and build a digester as a standalone system and source organic waste. Municipal digesters have been used as part of municipal wastewater treatment plants for a long, long time for conditioning normal municipal sewage waste. And then what we're talking to you about today is actually a co-located municipal and source-separated organics digester. And right now we currently have 2 different sites that we're working on developing these on in the Salt Lake Valley. And basically what we'll be doing is, I'll just get into this slide because this explains it better than I can. So in 1 year, a 500,000 population city produces around 70,000 tons of food waste. And Kate's going to get into a lot of the food waste and food waste statistics here in a little bit, and it's pretty mind-boggling. So basically from a city, you'll have sewage and you'll have the food waste. Food waste will go straight into the anaerobic digestion process. The sewage goes into a wastewater treatment plant, and then along with the food waste going into the anaerobic digester, the sewage sludge that comes from the wastewater treatment plant also can be co-digested into the anaerobic digester. From that, the water, after the digestion process, there is wastewater. That wastewater would flow back to the treatment plant and be treated as part of the wastewater stream prior to discharge into the body of water that it's located next to. Then from the anaerobic digester, we'll produce electricity and or gas or a fuel and a fertilizer product.
Okay, so one thing that I thought I'd mention is that, you might look at the two of us in a construction company and a recycling collection company and think like, how did the two companies get thrown together? And, for those of us, or for those of you who know Momentum Recycling, you know that we're a zero waste company located in Salt Lake, and our focus is on how we can help our clients move towards zero waste. So primarily what we do is we collect materials and take them to various end users in the valley. Any of you who live in this valley and who are passionate about waste know that one of the big missing pieces here in the valley has been food waste. For a very long time we haven't had an outlet. And there have been a lot of discussions, there have been a lot of studies, there have been a couple of sort of, false starts. We got excited about different projects and then they fell through. So a while ago, we got thrown together. I think it might have been Salt Lake City that pulled us together into a meeting with AllPro, and they walked through their this plan for an AD project, and we got really excited about it, and we wanted to get involved. So after a couple of discussions, we figured out that maybe one of the logical ways to get us involved is helping bring food waste to the plant. We have clients that produce a fair amount of food waste, and they've been looking for an outlet, environmentally friendly way to get rid of that food waste, and so now we have this solution. So these past couple of weeks, I've been kind of working through a feasibility study of sorts and looking at food waste in the big picture and trying to figure out, okay, if we've got statistics for our nation, how do we break those down? What does that look like in the Salt Lake Valley, and how do we characterize that, and how do we capture that? So some of these numbers that we've been pulling together are kind of mind blowing. The other piece that I wanted to share today is the connection between food waste and climate change. I think this is something that, again, if you're passionate and excited about waste, you understand this connection and you understand the importance of diverting organic material from the landfill. But if it's not something you've ever delved into, it's maybe a little fuzzy. So to draw that connection a little more clearly, I've been pulling some statistics, and I think one of the EPA statistics that I pulled was there are about 35 million tons of food waste generated in the U.S. annually. And if you were in this room for the previous session, I think Matt Abbott mentioned, that's about a third of the MSW that Park City produces. So it's a very, very significant, it's the most prevalent material in the municipal solid waste stream. And the very unfortunate and disturbing thing is that 95% of that material is landfilled or incinerated. And then, this is the part where this is the connection here to greenhouse gases. The provision of food waste, or of food in our country, is associated with 14% of our greenhouse gas emissions. And so when I say provision, it's not just food waste rotting in a landfill. This is, the greenhouse gases emitted during the production of food waste, transport, and then disposal in the landfill. And then again, those of you who have maybe more of a science background, when organic waste decomposes anaerobically or without oxygen in the landfill, it produces methane gas. And what a lot of people don't know is that methane gas is about 21 times more potent than carbon dioxide as a greenhouse gas. So all of that food waste that we're sending to the landfill is a major, major contributor to our greenhouse gas emissions.
Okay.
Is mine not working?
One thing that, for those of you that, from a business perspective, you've probably heard of carbon credits. People trying to reduce their carbon footprint, and a lot of the big corporations actually purchase carbon credits in order to reduce their carbon footprint as a company. And the carbon credit trade market is something that's kind of cycled quite a bit, but this is actually how a carbon credit is calculated. And one carbon credit is equivalent to 1 ton of CO2 reduction into the atmosphere. So if we, through our project, can reduce methane by 1 ton, then that's equivalent to 21 carbon credits. That's actually kind of an average. Some people say it's as low as 18 times. Other people have seen it as high as over 30 times more damaging. So that's one kind of just an explanation of carbon credits.
Thank you. Yeah, you're better at explaining that than I am. The other fact that I wanted to mention is that landfills are the largest source of man-made methane, or the largest emitters of man-made methane. Does anyone know who the largest emitter of methane that's not a man is, or a woman? So, as I mentioned, I've been trying to get my head wrapped around what Salt Lake City would produce in terms of food waste, and unfortunately, there isn't a whole lot of data out there. The EPA has some great studies. Cascadia Consulting has done a bunch of studies that are on the CalRecycle website if you're interested in looking into some of this. BioCycle has also done some great studies. So pulling some numbers from all these various studies, I've been making some calculations. So looking at the 2013 census puts the Salt Lake, actually it's the Salt Lake County at a population of about 1,079,000. BioCycle had a study. They had a sort of state-by-state rundown of the number of tons of municipal solid waste produced per capita in each state. So Utah came in at 0.94 tons, which is about 1,880 pounds a year. And then most studies point to about 14.5% of MSW being food waste. So that comes in at about 273 pounds of food waste a year per person. So that that's pretty significant. And you multiply that by the population in the county, and you get about 147,000 tons a year of food waste. So imagine 95% of that ending up in the landfill and producing methane gas. So that's fairly disturbing. And I won't go into this because I'm guessing that the next session is going to go into this with a lot more detail. But a big part of what we do at Momentum is talking to our clients and educating the public about why it's important to divert recyclables, why it's important to divert organics, and then not only just diverting them, but diverting them to the right end user in the right place in the right order. And so this is something that I think is important to examine, that our first level of diversion should not be the anaerobic digester. Anything that is still edible should be diverted to hungry people. And that which is available should be sent to feed hungry animals after that. And then generally industrial uses should come third, like the AD project. So, that one of the great unknowns in this study that I've been putting together is, so we have 147,000 tons of food waste produced. How do we get it to the digester? How do we get it to the right end users? And so studies I've been looking at say that food manufacturers, restaurants, grocery stores tend to be some of the largest producers of food waste. Massachusetts, for those of you who are following the issue, Massachusetts instituted an organics ban in 2014. And, they put out some sort of preliminary studies, and so, this is where I'm pulling some of this data. In their analysis, these tend to be some of the highest producers of food waste. So, in our analysis of what we can capture, we've been sort of trying to pull out, how many of these entities do we have in the valley, and what amount of food waste could we anticipate from each of these? What percentage of these generators do we think that we could capture? And one, the other thing that we're looking at is not, the message of environmental impact, as we heard discussed this morning, doesn't resonate with everybody. It's not a quick and easy sell. I think that there will be certain food waste generators, for whom it's a no-brainer. They've already bought into the environmental message, and once they hear about this opportunity, they'll be ready and willing to leap into diverting their food waste to the digester. But then there are, other sectors of the population, for whom green is a bad word, and that's not going to be a compelling message to them. So, we have to frame the argument or the message in a very different way. And we've in selling recyclable service and diversion services over the past 7 years, I've come to discover what kind of message resonates with what kind of person. So, we've discovered that sometimes, just focusing on the bottom line and focusing on cost savings can be a compelling message, or thriftiness, that, this is a better use, a wiser use of resources. This is not wasting what we're creating, and that can be a more compelling message. But I love sitting through that session this morning, and then I'm actually going to go to that workshop tomorrow, so hopefully I'll find some new ways to frame things in a positive light, focusing on, maybe changing social norms going forward. And then the other factors that I've been looking at that I think will place some barriers to capturing food waste in this market are low landfill tipping fees. Utah has some of the lowest landfill tipping fees in the nation. If you go back east, or if you go to Europe, or even some places in California, landfill tipping fees are 10 times what they are here. So there aren't the same kind of incentives in place to divert food waste that there are in other localities. Negative attitudes related to environmentalism. I mentioned that in relation to messaging. How do we frame that message and make it something palatable? Lack of incentives for haulers in the waste industry. One of the attitudes that we encounter pretty frequently is, well, I want to recycle, but if it's going to cost you more money, then, what's the point? There's no sense in doing that. And why doesn't recycling make me money? And, why don't I get a kickback? We get these questions all the time, and I'm assuming that we're probably going to get these same sorts of questions related to food waste. And, until I became part of a company that runs big trucks and hauls materials for a living, I didn't have a very good understanding of this. And we don't haul landfill waste, so, my picture still isn't entirely complete, but in discussing this with other haulers, the reality is that, if you have one container, and it's a big container, and you're hauling it to the landfill with some frequency, that's the most effective use of their material, and it costs them, as a hauler, it costs them the least. If you keep adding containers and you're sending more trucks to, take those containers to different places, you got one container that's taking stuff to the landfill, you got one container that's taking your organic material to the digester, you got one container that's taking your recyclables to the sorting facility, it costs money. So unfortunately, in our state currently, with the landfill fees and a lack of ordinances that are requiring a particular rate of diversion, there aren't really incentives currently in place for haulers. I think that's something that going forward, it's something that we can work on, but behavioral change takes time, and changing social norms takes time. So, hopefully we'll be moving in that direction, and eventually can make some change. The one last issue that I wanted to mention in terms of challenges our business's perception around organics collection. And this is something we've started to encounter in just sort of beginning to discuss the issue with some of our current clients. A lot of our current clients are collecting green waste already, and they're diverting that green waste to composting facilities. But when you mention food waste and you're talking about meat, dairy, oil, immediately everyone starts thinking about, well, maybe some people start thinking about the scent of rotting meat, or rotting food and the smells associated, the odors associated with it, and then the fact that.
Try this one.
Hello? Okay, can you hear me? Go back online. Where was I going with that? Voters, thank you. People are freaked out by the thought of rotting food sitting around, and the one aspect of this project that I think will help encourage people to move beyond some of these issues is that it would have a depackaging system in the receiving area. So this means that we would have the ability to accept materials in plastic bags or in bin liners. So hopefully, that would help people, get around some of the ick factor of collecting food waste. And then the other thing that we tell our clients frequently too is that stuff is sitting in your waste bin now anyway. So just because the waste bin will just be dedicated to that material doesn't mean that it's going to somehow respond differently or behave differently in that container than it is in a container of just landfill waste. But again, source separating that material takes time, it takes space, and it takes energy. So these are barriers or perceived barriers. But I think that hopefully if we can walk people through it over time. Hopefully if we can talk people through some of these issues, and if we have some early adopters that we can use as success stories and who are able to share some lessons learned, then I think that hopefully we can make some progress on this front.
Okay. What time do we finish?
We have to be done with it.
Okay.
Yeah, a couple of minutes. We want to take some questions.
Okay. I'll fly through here the rest of this, what I had pretty quickly. So we basically have feedstock options. WAS is waste activated municipal sludge from a normal sewer treatment plant. FOG is fats, oil, and greases. Liquid food processing waste is more full truckload quantity type waste. And then source separated organic waste, which is what Kate's been talking to you mostly about. And then packaged food waste would be basically exactly what it says. So what do these things look like? These are basically piles of waste that are at a facility just outside of London. Actually, our technology provider on the depackaging, this is their facility just outside of London. But this is a basic process of how our system will operate. This is the food waste coming in. There's a waste pulping and screening process that takes place, and then it's liquefied to around 6 to 7% solids when it's fed into the digester. This is what the packages will look like after they've gone through the depackaging system. Essentially, everything comes in, gets dumped on the floor, gets loaded into a grinder, it's ground up. The grindings are it's screened, and then these are the screen, and it's washed. So once it's screened and washed, this is what's left, which is basically around between 7 and 10% of what's brought in ends up as waste to the landfill. So we're going to be looking at different energy offtake options with the project, and we'll pick the best one from an economical standpoint. Right now, we're leaning towards probably a pipeline grade gas offtake rather than a power offtake, but that's still yet to be finally determined. So our project will take the current gas production from the wastewater plant, and it'll make it about 4 times what it is currently as their current gas production. So they'll be able to be self-sufficient electrically, and heat off the engines could be utilized in a combined heat and power process. I'm going to go through these quick so we have time for questions. But we have the biogas can be burned in a boiler export electricity. You could upgrade and export the CH4 or the methane into the pipeline. Some projects are doing a CNG or a compressed natural gas or an LNG, which is a liquefied natural gas. It's a little bit tougher to do CNG and LNG on projects this size because CNG has to be stored, and you're producing, our project will produce around 2.5 million cubic feet a day of methane. And when you look at that quantity of gas, it's pretty much impossible you'd have to have a huge fleet of trucks or transportation vehicles of some kind to use that much CNG every day. And LNG is usually reserved for larger quantities than that. So pretty good chance we'll probably be exporting our gas as pipeline grade gas into the pipeline. So from the soil standpoint coming off the back end, currently they produce a Class B type solids. It's applied for land application in non-food related agriculture. And they also make a compost product with it that is marketed as a compost. This Class B biosolids, or Class A biosolids is what the compost is, and you can just come and buy that as a consumer. Our process will actually recover the nutrients from the waste stream that are going out in the liquid. So we'll recover the NP and the K, the nitrogen, phosphorus, and potassium, get it into the solids, and make a carbon-based fertilizer product that will be marketed and sold as a carbon-based fertilizer rather than just as a compost product. Needless to say, the waste that's coming out of the digester actually makes an excellent base for composting. So the reason why that is the process that takes place inside of the digester actually breaks down the odor-producing compounds and the things that make compost smell. So coming out of the digester is more like a soil, like a kind of a dirt, and all of the methane that's produced during the composting process is captured rather than released into the atmosphere like it is in traditional composting. So all this sounds great. So why isn't everybody doing it? That's an artist rendering of our project. Low landfill tip fees are a big deterrent from this project. Low utility costs to offset in the Intermountain area. Our utilities are low. As Kate mentioned earlier, there's no ordinances in place to require organics diversion, and it's absolutely impossible to reach a 50% diversion rate without diverting organics. One of the biggest reasons why this project works in Utah and in the model that we're talking about is because of its size. It's a very, very big project. Our project will be around $25 million. And that's a big investment, but because of the size of the gas production that comes from it, it makes it economically viable. That's the same reason why it takes so long to develop these projects, is because it just takes a lot of time to secure all the waste that's needed to operate a facility this size. I put in here 25 million versus 35 million. So just real quickly, our project here in Salt Lake will produce around 2,500 decatherms, which is 2.5 million cubic feet a day of gas. We're doing a project in Phoenix at a large dairy operation that will produce 6.5 million cubic feet a day of gas, and the capital expenditure is only another $10 million. So the size of these projects definitely makes them economically viable. And the single biggest deterrent for these projects is it takes a long time to develop them, and it takes a lot of financial staying power during the developmental process, the pre-engineering and all that, to get to where we are today. We've basically had to cover 3 years worth of engineering costs and 3 years worth of development costs to get to where we are, and we're still 6 to 9 months away from being able to break ground on this project. So it's an exciting project. We're thrilled to have it here in Utah. It's going to be really one of the first of its kind in the U.S. There are others, but definitely one of the first of the kind in the Intermountain region. But it's a long, tedious process, but it's exciting at the same time. So, any questions for us?
Good time for a few.
Where is it going to be located?
There's 2 different sites that we're looking at right now. One is at the Central Valley. It's a co-location with the Central Valley wastewater plant, and then another one is in kind of the South Davis area, of Davis County.
Other questions? Yes.
You mentioned earlier that you need a bankable feedstock. What does that mean in terms of tons secured?
Well, it's really a broad range of different types of feedstocks. And the food waste, honestly, there's a lot of energy in the food waste, but the quantity is relatively low in comparison to some of the other feedstocks. So we'll be taking municipal biosolids from other wastewater treatment plants around in the valley that don't have anaerobic digesters. Those are nice bankable contracts because they're contracted with other municipalities that we can work with. And then some of the large food waste producers from food processing facilities can be long-term contracts. So those are bankable because they're large quantity with big entities. And honestly, the food waste is something that it's harder to finance that because it's from a lot of different individual locations. So we'll first and foremost we'll look to the single biggest producers, and we've actually already entered into contracts with large haulers and large waste haulers that are currently doing that work. So some of those long-term contracts are already in place. Okay, go ahead.
Yeah, could you give us a sense of these big numbers, how many houses will they supply, like the gas, like you mentioned, thousands or millions?
It's a good question. Let me think about that for a second. I'll come back to you. Go ahead.
How much leachate do you plan on producing, and how much is that as a percentage-wise part of this project? To see that you have a little bit of water going back to the wastewater treatment, how much is that?
Yeah, it's not a huge quantity. It's around a couple hundred gallons a minute is what would be going back to the wastewater plant. But as a result of what you think about the quantity that they're currently dealing with, the Central Valley plant, it treats 75 million gallons a day of wastewater, and so we'll be around 500,000 gallons a day going back to the head end of the plant, and most of that is just water that's coming out of what's hauled in, because food waste is around 20% solids, 20 to 25% solids, so it's 75% water. But we'll actually have a part of the nutrient recovery process treats that side stream and pulls the nutrients out and gets it into the fertilizer product. So the water that's going back to the head end of the plant is actually cleaner than what they're currently treating.
My question was about the overall net carbon reduction, because at the end of the day, people are still using natural gas, the product of this. So what's the net carbon reduction?
Well, that natural gas is basically what we're doing is it's a green gas source. So the methane that we're producing and putting into the pipeline is methane that isn't going into the atmosphere that used to be. So instead of it going into the atmosphere, it's going into the pipeline to be treated.
Have you done an overall life cycle analysis of it?
We haven't. I guess we could answer that question for you, but I haven't yet. Yeah. Dwayne.
Just out of fairness, I guess landfills have done a lot to change the old ways, in that it used to be always, all the stuff went in there was let out in the atmosphere. But most landfills now have gas collection systems that are beneficially using that gas instead of letting it in the atmosphere. We produce 4 megawatts plus of power every day from gas that used to go in the atmosphere, and it's not anymore.
Yeah,
So,
I'm glad you brought that up because I wanted to I saw you back there.
because you can't use that at 100% as an argument, because it is being beneficially used.
Right. Yeah. But
AD plants are great, but we ought to do more of them.
a lot of the landfills don't all have gas collection systems. They have to be kind of designed that way. But I'm glad you brought that up because it's a great point.
I was actually going to ask a very similar question. If you could explain the difference between the methane that's being captured in pipeline at the landfill and what you will be doing.
Yeah. The one advantage on an AD process over a landfill is that it's a cleaner gas. The waste is you don't have a lot of the things that are like chemicals and that kind of thing that would be in a landfill that would produce a dirtier gas. Dwayne can probably talk to this a lot better than I can, but it's it's harder to clean landfill gas than it is to clean biogas.
It is, and it's one of those things that, you know, what you're suggesting is a great process, and it is better than not doing it, but it's not the only answer. You know, we need to have a little both, because you're still gonna have stuff going to the landfill, and you still gotta collect the gas.
Right.
And so, we're not doing away with landfills, but we're improving the way we're taking care of those.
Right.
But like I say, a homeowner putting their this is Dwayne's opinion, but a homeowner putting their food scraps in the garbage is better going to landfill than it is another truck, you know, and everything else to take to a, you know, the big plants that you're talking about are good to go to, you know, the ones that are producing a lot of food scraps at one location.
As long as it's going to a landfill that's covered.
That's right, and it has to be a landfill that is collecting, because not all do.
Okay.
I think that kind of fed into my question of what is your first focus as far as where to collect waste initially? Is it like large restaurants and cattle, or is it homeowners?
Yeah, honestly, probably the lowest hanging fruit would be curbside pickup. It's very, very hard to, not only is it hard to regulate, it's relatively small quantities in comparison to large food producers, universities, hospitals, those kinds of things. That would definitely be the first priority. Grocery stores, convention centers, that kind of thing. Like Dwayne's referring to the curbside pickup, that's probably a long ways down the road.
Okay, one. Okay, any other questions? We got time for one more.
Just to expand on that.
Does this work? Just to expand on that, the challenge with residential organic waste is that a lot of that waste is yard waste, and yard waste unfortunately isn't as great a feedstock for anaerobic digesters. So I think, you know, municipalities that are looking at food waste programs generally tend to think of, you know, two different systems to deal with those materials. So an AD system is a better system to deal with commercial food waste, and then a more traditional composting system can be a better way to deal with yard waste.